In this video, we will see how to enable or disable test cases based on some conditions. So for instance, I have added a dummy test in this test class. So we have two JUnit test cases in this class. If we run this class, it will basically execute these two test cases and we should see the status of two test cases on the console. So it is running both the test cases and we see both the test cases passed successfully. Now, for example, maybe you found some bug in the code and you don't have time to fix it, or maybe you found a bug in the implementation of test case and you don't have some time to fix this test code, or maybe this is a legacy test case, it's no longer required, or whatever reason. For whatever reason, if we want to disable it completely for the time being temporarily, what we can do, we can use an annotation disabled. Disabled means this test case is disabled now. So whenever we are running this test class, either manually or via the automated CI/CD pipeline, this test case will be ignored. It will not be executed. To test this, we can run the test class again, and this time we should not see this test case getting executed. So we see dummy passed successfully, but this test case was ignored. It says this is disabled and we see this sign. Okay, so that means this test case is disabled. So JUnit framework simply skipped executing this test case. Okay, we saw how to disable a test case using @disabled annotation, but there's more. JUnit framework has many annotations that can enable or disable test cases based on certain conditions. We will not cover them, but we will simply go through the documentation and we'll see how to use that. So for example, here we have @enabled on OS, similarly @disabled on OS. So we can provide the operating systems, and depending on the annotations that we use, the test cases will be enabled or disabled. Then we can also provide the architecture. For example, enable this test case must be disabled if the architecture is x86_64. We have similar annotations that can be triggered based on the Java runtime. So here it says enabled on JRE Java 8. That means if the JRE is Java 8, then only enable this test case. We can also provide the range min max enabled for JRE range. Similarly, we have annotations to disable the test cases. Depending on the version, we can also provide the range. Then we can use native images enabled in native image, disabled in native image. We can also use system properties. The annotation would change if system property, and we give the name of the property and the value that will decide if the test case should be enabled or disabled. We can also use environment variables similar to system properties and custom conditions. @enabled if, then a custom condition can be given similarly to disable the test case. So lots of things related to enabling or disabling a test case, but there is ample information in the documentation and we can get that information from the documentation. The last bit that we need to cover is assumption. JUnit supports assumptions, that mean assuming that we need to do something. We can make some assumptions in order to run the test cases. Let's see what do we mean by that. So there is a class assumptions in JUnit that has methods like assume false, a condition, then assume true, a Boolean condition, assume that a Boolean condition, and then executable, assuming that a Boolean condition and an executable. That means if we use this method, then assuming that this Boolean condition is true, it will execute the executable. Whatever we pass in the executable, that will be executed if this Boolean condition is true. So we are saying that assuming that this Boolean condition is true, then we want to trigger something as part of the executable. So let's use that. The first argument is a Boolean value. So we will see how to pass that. And the second argument is executable, which is a functional interface, and we have already seen how to use that. Here we are using the executable. If we see the method signature, then you see the second argument is executable. So all we need to do is we need to pass a lambda, and whatever code that we want to execute, we would simply pass that code to this executable. Okay, so let's move all these assertions to this assumption. And now we are saying, given this Boolean condition is true, then only trigger this code, then only validate the conditions. But how do we pass a Boolean condition? What kind of Boolean condition that would be? So we can pass any Boolean condition. For this example, let's say we want to assume that a certain environment variable is present. So we can convert that in a Boolean condition. Let's try to do that. So we can pass an environment variable. We just need to modify the run configuration. So here in IDE, we can pass the environment variables from this section. So we would say, let's have an environment variable assumptions and value y. So we would say, if this environment variable is present and its value is y, then only assert all those things. Apply, okay. And now we need to write a Boolean condition. So we say system dot get env, name of the environment variable. So we are saying check the environment variable. If you find a property or an environment variable with name assumptions, test its value. If it is y, then all these assertions will be triggered. Okay. Now we execute the run configuration from here. So that's what we did. And we see the test case passed successfully, but we have no idea if all these assertions were triggered. So let's add a message also and run it again. So we see this section was triggered because we have an environment variable with value y. But what if we change the condition? This time we say that the value must be y1, but this is y, so this condition is now false. And in this case, because this assumption is no longer valid, so it should not trigger these assertions. And that's what it did. So we don't see testing this message on the console because the condition is no longer true. So we can use certain conditions and we can trigger the test case, the actual test case based on that condition. Okay. In this video, we will talk about the concept of code coverage or line coverage. In simple terms, it means how many lines are being covered by the test cases that we have written. The more lines we cover, the more confidence we will have in the system that if we make a mistake, that will be caught by the test cases. All right. But in order to improve the line coverage, we will have to write more test cases. That means if we have a method, the target should be to write a test case or test cases that can cover all the lines, all the branches, all the code paths of that method. Then there are tools to calculate the code coverage, to monitor the code coverage. And nowadays, most of the IDEs, they have inbuilt a mechanism to capture the code coverage. So here we have a simple class and a simple method that has a condition. So that means if the number is is even, then it returns true, otherwise it returns false. And right now we have an empty test case. It means it's not covering anything. So with the help of IntelliJ's inbuilt tool related to the code coverage, if we run this test case with coverage, it would show the current coverage. So we see that it triggered the internal code coverage runner, and now we have some data. The yellow line here, if we open the setting, the yellow line here shows the uncovered lines. If this is covered fully, then we would see color highlighted, this one. If partial, then this one. But right now this is yellow, so that means this is uncovered. So we see all the lines, all the code branches are uncovered. This is a branch, this is a the if condition, and this is the second branch because this is the else condition. So right now we are not covering anything. So let's try to write a test case to cover some conditions. So for example, we wrote a simple test case to cover the condition if the number is even. So we say that assertions dot assert true ops dot is even, and we passed an even number. So we know that 2 is an even number. That means this branch, this if branch will be triggered and we will get a value true. So this test case would pass. So this time we see the color has changed. It means we are now covering these two lines, basically this if condition, but this condition is still not covered by the test case. That means we don't know if the number is not even, we don't know what the outcome will be. What if this code has a bug in one of the future commits? What happens then? Because we don't have a test case that is capturing this line, it means anything can happen. We cannot be confident when it comes to this portion of the code. So ideal way would be to write another test case to cover this condition as well. So let's write another test case. In the same test case we will add another condition, that assert false is even, and let's pass an odd number this time. So we are saying that we are covering both the conditions. If the number is even, then we should expect true. If the number is false, then we should expect false. And this time we see that all the lines are now covered. It means as of now we are covering all the lines of this method. This is fully covered. So if there is any bug in future, let's say I made some bug in this line, maybe instead of 0 I'm writing 1, but that will be caught by this test case. All right, so that is the purpose of covering all the lines. Additionally, we can also have the reports related to the code coverage, and I think I should be able to find it on the IDE, this one. Yeah, so generate coverage report and open generated in the browser. Let's see. So here we see we have a summary of the code coverage generated by the IDE, and if we go to the math.ops, then we see the all lines are covered. If we go back to the greeter class, we see that I believe this is not covered because it's a different color. So that is all on the code coverage.